how should people be thinking about these digital twins? Like when you talk about these machines, what are they like? Why are they being built, and who's building them?
Well, so we've reached a point where the systems that we've built are no longer just tools, they're agents, right? So they're interpreting our data and they're simulating our decisions. And in some cases, they're replacing our judgment. And the ghosts in the machine are a digital version of us that acts without us. And that, to any sci-fi
Yeah.
lover is
Yeah.
is
It's very
like
cool. Very scary. Very cool. Right. Yeah.
it could be scary or it could be completely amazing. The thing is that we need to be active participants in determining that outcome, right? Because the thing that we're calling the ghost, it isn't artificial. It's made from our lab results, our biometrics, our genomes, and our behaviors, and it's us. So right now, it's being used in most cases without our consent and without clarity, and certainly without compensation. And so that is the part that's very concerning to me. And it's clear, right now that we're in a world where innovation is, outweighing legislation, very publicly. And as a technologist and as a futurist, that's very exciting, right? But as a husband and a father and a son, that is very concerning. So, how do we balance those things? Because if we don't reclaim the ghost, if we don't put boundaries around how it behaves and who owns it and how it serves us, then we've created a future where the machine doesn't just haunt us, but it's running us. The thing is that I'm very optimistic, though, inside of all of it. And if we get it right, and if we build systems that are rooted in truth and in transparency and in trust, then that ghost, it becomes a second self for us. And it extends our reach and it amplifies our care and it protects our autonomy. So the opportunity is that we have time to build this.
Yeah, it's interesting. I think about it, even as we were talking about it, I'm immediately imagining like the avatar, but in reality, the machine is maybe like more diffuse than we think of it. It might be, a simulation of a heart, right? It might be the simulation of certain progression of disease, right? It might be a prediction about the impact of a particular type of medicine based on your genome. Like you were just naming all these different
That's right.
types of data. And
That's right.
so I think for our listeners, like, are there parts of this that you think are maybe safer or more dangerous? Is it all kind of the same? Do we think about it, in terms of a varying set of risks across the spectrum?
Well, if things are nascent right now, right? Because patient data is going to be scattered today, like across things like EHRs, lab systems, wearables, apps, insurers, and none of it's unified, right? So is that good or is that bad? Well, in some ways, from a diagnostics perspective, that's not great. But in other ways, from a safety perspective, well, if you have a complete catastrophic failure or security breach in one of these silos, well, at least it's not everything, right? And so today it's a little bit of a trade-off. But as these systems become unified through platforms like Palantir's ontology data ontology system, right? So they've figured out ways of managing warfare on a global basis, right? So you could only imagine how disparate and siloed all that data is. So being able to point that at other industries like financial services or healthcare, similar things could happen. So once this data is unified, then we can unlock some of that magic. But the issue with the fragmentation is that the models that we have today struggle to create coherent views. And what we get then with these models is what is known as these hallucinations, right? So if it has incomplete data, it just makes shit up. And that is the most terrifying thing in the world when it's 2 o'clock in the morning and you have a sick child and you're trying to get an answer and you're using a corpus of data that has some peer reviewed information in it and has some diagnostic data. And maybe I just uploaded, the information from my pediatrician yesterday, but the rest of it was trained on my fourth grader's homework, right? That's not a great situation to be in when you need critical information for decision making.
Yeah, I think I always kind of think about the interdependencies of things. Having worked in life sciences for a long time, I always think about how little we actually know, right, about human biology, right, and chemistry. And it's gotten better, but it's still not a whole lot. And we're doing an enormous amount of prediction through what I think of as inference, right? So we infer things from small amounts of data, sometimes deep data, sometimes small and broad data, but the level of inference is really high. And when you localize inference, right, you get a localized view of it. And then if you ask an expanded, like it feels to me that there's this risk in, like, the smaller you get, the smaller the question, the more sure you are about the data and the better it is, and the more likely it's completely wrong based on everything else that you know at the same time.
100%. And yeah, I don't believe that we have AI today. I believe that we just have these morph engines. We are relatively good, great in some cases at pattern recognition. But beyond that, these systems aren't, alive or living, right? Anybody who's telling you that, we're close to artificial general intelligence, it's not true. We can't get there through the systems that we have today. We have to do some other things with the technology, and we're starting to see that come out, right, as new forms of matter are being created by companies like Microsoft, right, in order to get there through quantum and biological computing and other things. But that's just it. We don't have a fully bright or capable system that understands us or our systems in any way. So it just it makes up the rest of it.